Okay, this video is going to explain how to write the names of ionic compounds. I've grouped it together in 3 different groups, kind of like we've been writing the formulas. And then I have a couple of reminders up here at the top that need to be followed every single time you do this. The first one says always name the cation first and the anion second. The second one says for every single one of these, you need to check to see if the metal needs a Roman numeral or not. So a little bit about that before we go on. If you remember from class, we have said that all alkali metals, all alkaline earth metals, those are group 1 and group 2 elements, aluminum, silver, zinc, and cadmium, they do not get Roman numerals. Everything else that's a metal will have one. So here on the periodic table, you can see we're talking about the first 2 groups and then 4 elements that are right over here. Anything else, if you have elements that fall outside of that, then for what we're going to do in our class, those other elements will get a Roman numeral. The things that I put in yellow will not. It also means that you're going to have to memorize the charges of silver, zinc, and cadmium. Silver is always +1, zinc and cadmium are always +2. About the only trick I have to remember that is that this is 1B and 2B. Well, silver's in 1B, it has a charge of 1+. Cadmium and zinc are in 2B, so they have a charge of 2+. So now we go back to actually naming some of these. Alright, so when I do the first ones, if I look at my periodic table and I look for the placements, I'll see that lithium is not one of the ones that needs a Roman numeral. So all I do is name the ions. This will be called lithium oxide. I just name the lithium and I name the oxygen. I do the same thing with this one. Calcium is a group 2 metal, so it doesn't get a Roman numeral. So the name of Ca is calcium. S stands for sulfur, but when I do these, I have to change the endings to end in IDE, so it becomes sulfide. Then I have Al2O3. Aluminum is one of the 4 that I named that kind of sits over by itself that doesn't get a number. So I'm going to write aluminum. And then oxygen will become oxide. So the name of that one is aluminum oxide. Now, the ones that have either transition elements or things that don't exactly play by the rules as much, I kind of put here together some things for us to consider. Iron is a transition element, and it's not one of the elements that I named, so it does have to have a Roman numeral. So like the other ones, I know it's going to be called iron. It's going to be called iron something oxide. The something is important because the one underneath this is also iron something oxide. But if you look at the formulas, they're definitely different. This one has 1 iron, whereas this one has 2. In order to figure out the Roman numerals, I'm going to have to figure out how many electrons those irons were able to lose. So I'm going to work a little bit backwards. In this top one, I know it's 1 iron and 1 oxygen. I also know that oxygen has a charge of -2. That means the iron has to have a charge of +2 if there's only one of them in order to add up to 0. So that means my iron is iron 2. This iron oxide has 2 irons, so it's got 2 and it's got 1 oxygen. Well, again, oxygen has a charge of -2, but this time I have 2 irons that it took to cancel out the -2 because they're both +1. So this one will be iron 1 oxide. Alright, zinc and chlorine. If I'm using what I know about the periodic table and I look at it, zinc is one of the elements that I told you would not get a Roman numeral. It's one of my 4 elements over here with silver and cadmium. So even though it's with the other things that normally get Roman numerals, I'm not going to give it one, and it's going to be called zinc chloride. For PbO, I know that's lead and it's oxygen. Well, lead is a metal, but it falls outside of the ones that I told you to know. It's not in group 1 or 2. It's not over here in the little 4 that I gave you. So it does have to have a Roman numeral. So it's going to be lead something oxide. If I do my work, I'll see that it took 1 lead and 2 oxygens according to my formula there. Well, each oxygen is -2. So if it took 1 lead to cancel out 2 -2 charges, then it has to be a +4. So I write the Roman numeral for 4. It's lead 4 oxide. This is probably going to be your most difficult case. Now we switch over to polyatomic ions, which actually should get easier. How I know when I look at a formula that it has a polyatomic ion is right here in red. It says anything with more than 2 elements has a polyatomic ion. So use your polyatomic ion chart. So if I look at the first one, I see 4 different elements. I see sodium, carbon, hydrogen, oxygen. So something there has to be a polyatomic ion. Most of the ions, if you look at your ion table, are negative, so there's a really good chance that the very first thing will be just a regular old ion, and then the rest of this thing will be a polyatomic. If I look at my polyatomic ion table, sure enough, I see right there, I know it's little, it's C2H3O2. So I'm just going to name both of them like I did before. Sodium gets the name sodium. Sodium is not one of my metals that needs a Roman numeral. It's an alkali metal. And then this thing it says is called acetate. So I'm going to write down sodium acetate and I am done. Beryllium. Beryllium is a group 2 metal, so it doesn't get a number. So I'm going to write on my paper beryllium. And then the parentheses help me out a lot by showing me what my polyatomic ion is. And I look it up on my chart and I see that it's called phosphate. Potassium and SO4. Well, potassium is a group 1 metal. That means it doesn't get a Roman numeral. So I write down the word potassium and I look up SO4 and I see that it's called sulfate. FeCO3. I look this one up and I see that it's not a group 1 or group 2 metal and it's not one of the 4 that I mentioned. It sits right there. That means it will have to have a Roman numeral. So it's going to be iron something. If I look up CO3 on my polyatomic ion table, it's called carbonate. And if I look it up, I'm going to have to do some work like I did over here to the left. The Fe, there's 1 of them, and CO3 travels as a group. Well, my chart says CO3 has a charge of -2. If it has a charge of -2 and it only took 1 iron to cancel it out and add up to 0, then iron has to be +2. So my formula for that is iron 2 carbonate. This is how you do the ionic formulas.